All right, how we doing, folks? Let me pull this up. All right. If you can see Fly to Learn resources, please raise your hand. All right. Go ahead, raise your hand so I know that you see us and hear it. All right, awesome. We're going to get started tonight. This is the second lesson. I've automatically added 2 more lessons 2 weeks from now. You don't have to come to those, but those will go into more detail if we don't get through all of it here. And it'll be great for someone who wants to make up or deeper dive on the more advanced topics. So it's already, if you've signed up to this, you're already signed up. You don't have to come to any of these. If you want to come to that, that's great. All right. Now, as I said before, let me make sure everything's recording here. Yep, it's recording. A little bit annoying on this Mac for whatever reason. I apologize, folks. I've taught a full day. I've got a group of students, just finished teaching them, and when I get off this webinar, I'm going to go back and teach some more. So I apologize for my voice, but should be set to go. Go ahead and put your hands down. If I can avoid clicking on the GoToWebinar stuff, I will, because it's going to blow the screen off. It's very annoying right now. Not sure why it's doing it, but when I do this, so if I lower the attendees, it automatically pops it down like this. And by the way, you see that's the solar eclipse. I got to see. I don't know if people saw that. It was pretty cool. All right, well, let's go ahead and get started. Again, sorry for this popping back and forth situation. Maybe I can do it this and do a new tab. I can stay. No, see, it's just going to keep me doing that. That's really very. See, the minute I move that, it pops us up. Sorry, guys. All right, there we go. But let's just go ahead and get in here and what we did. What I wanted you all to see, if you want the answers to most of the stuff to teach your high school curriculum, the Gamma Aviation Design curriculum is just got for the design. You don't even have to worry that till we get closer to the competition. Again, the competition, if you're here doing the competition, is you're going to design an airplane. We'll give you some criteria. It'll start in April or a little bit sooner. They'll give you the start dates. Finish up. Best score wins. The winning team actually gets to build an actual airplane. But and in that curriculum, there's something about once your kids have gone through these basic information, then this makes a good advanced deep dive for those that really want to get into it. I would highly recommend getting, if you can, you teachers, getting a aviation advisor if you can, or an engineer. Be great. So we've had winning teams that haven't had those. Sorry about my voice is getting worse and worse here. All right, so let me go ahead. When we talked last time that the Fly to Learn is really composed of curriculum that's right here, and then power slideshows and videos. And we really only have videos to the beginning of this until once you get into pot wing design, we're really not using video so much. We just use the PDFs. Okay? But you can watch the Fly to Learn webinars, and we will go through it. And today, that's one of the things that we're going to go ahead and do. All right? Does everybody have that? All right, making sure there's no questions. All right, sorry. First is you got to click back on it and pull it off. All right, let me go up and pull up high school curriculum so y'all can see it. Teacher. All right. All right, so now, and then the gamma's after that. But, all right, so there are 1, 2, 3, 4, 5, 6 basic science of flight. There's advanced topics, which you don't even need for the competition, but they are there if you want to take a deeper dive with your with your other students or teachers you want to understand more. Engineering of flight, we go from science to applied. We talk about aspect ratio, wing loading, power loading, airplane design. Actually, by the 10th lesson, you're actually designing this. Now, advanced topics wise, you have gliding, jets, runway design, supersonic flight. Okay? So, one thing conceptually as you're doing this, just a review for, we got a couple new people here, is when we started this out, it was meant that we were going to teach engineering, and aviation was going to be our big draw to it because we think kids enjoy aviation. So if you notice the curriculum, it's not a lot about how to fly airplanes. The first 5 lessons will teach you how to fly the airplane, but it's not to teach you to be a pilot. You would need to be more in depth. Down the road, we will probably be offering that, but right now, as of now, we don't. All right? So I'm going to go real quick, and we'll use the slides, the resources slides that came through this. I'm going to go particularly quick because we've covered this, and I want to make it worthwhile to the people that were here last. So back to resources again. All right. And so just real fast through this. Well, it loads up. We talked in the first lesson. There are videos to go with this in print, but basically teaching you how to take off. Remember, the quick flight setup is where everything occurs. Let me see if I can get this done. See if I... Go figure. All right. So when you take a look at that, let me see if it maybe looks better this way. Okay. So here's a quick flight setup. You select your airport. You select your airplane. Suggestion again, use a 172. Don't go other ones. All right. On the bottom right on your screen here, check show this window every time it's start up. It'll bring that up. Go back to my previous slide, fly with these options. You know, we talked about in there, it talks about what these instruments do. We're just going to go through that now. All right. He also talks about the help and the above menu. You can do that. You put your mouse over the instrument, it'll tell you what it is. I'm trying, guys, to get through this. All right, takeoff. Just real briefly on takeoff again. There's a pattern to it. You pause. You press P to pause when you're in the airplane. You click on B or click on the brake light, turn that off, and then press the throttle down. Unpause it and fly it. So that's the throttle. You press that in. This is unpaused. If you click up here, you don't need a joystick. You can fly it with a mouse. Press P to unpause. You watch it as you go rolling down the runway. You press 80. It shows you in the video how to take off on this. As I mentioned last Tuesday, sometimes it's good to let the kids crash and try to take off a couple times. They're more likely to listen to you on how to do it. And we talked about how to go in and out, and we did the controls on the airplane. What a loop is. Ailerons do that. Roll, I should say, be careful. Roll, pitch, nose up and down, yaw, left or right. All right. And then, we move those up and down. One thing that first lesson does get into is it honestly gets into, on these slides, potential and kinetic energy, which is so important in an airplane. Okay? Now, I'm back. That's why when there's usually a crash, the planes are low and slow. They're running at an energy deficit. Once they get up high, they have a lot of energy and potential energy. They're going fast. All right. Now, back here. That's just going to be annoying. All right. Real quick, in the way presentation, that one was just basically we're going to add weight to the airplane and do takeoff distances. I do want you to see that this has the capability. We have the last video. We'll make sure they're all posted. Give me the weekend to post them. They'll be all up. But using data input and output, you can collect speeds, distance travels, vertical landing forces. And from there, by looking at the vertical landing gear forces, when all three of the landing gear are off the ground, we say the plane is in flight. So you'll get a data table like this. And where these three, in this case, the red and yellow, when all this landing gear values are 0, then you're ready to go. And if this is 0 here, then we look at, well, what's the distance traveled and compare that to true. And you repeat with load 6 and 900 pounds. All right, I'm gonna go next one. And what this really gets into, the final thing is about the moon. We teach the kids the difference between, remember we talk about weight is mass times gravity. We realize if you go to the moon, there's a lot less gravity. Therefore, while your mass hasn't changed, your weight has. And on the moon, if we put some air on it, in a crater or something, you can be able to fly like a bird. It's pretty cool. And they learn when they do this, takeoff distances go down dramatically. There you are. Okay, let me go back here. We study lift by stalling the airplane and looking at the lift vectors. There's two major values on flying an airplane: angle of attack and airspeed. So when the plane falls out of the air, stalls, point the nose down, you're going to gain airspeed. You learned in the first lesson, by the way, pointing the nose down gains airspeed, pointing the nose up gains altitude. Point the nose down, you start gaining a lot of airspeed, but to get a lot of lift, add a little, pull back on the stick a little bit, and you get, again, I'm apologizing, guys, you get a lot of lift. We're running through this, more details than the last one. So under special, if you do show flight model or hit Control M, you can see the left vectors and the wings of the airplane. And, you know, you can look at the lift vectors. It's really great. And honestly, a lot of pilots sometimes don't understand that we're showing them this. And again, we'll have the answers there on the presentation slides. Okay. So what we did is we'll have the kids stall the airplane. They'll see the left vectors drop off dramatically. Then they'll point the nose down, go down at left vectors to start increasing because airspeed's going up. But the minute you hit that angle of attack, it goes really fast. All right, so this is angle of attack and relative wind. This is the angle of incident, which is built in to the wings of airplanes, so the plane isn't always pulled back slightly. So the pilot, the passengers are sitting flat because the wing is slightly twisted up, giving that maximum angle of attack. And so angle of attack is related to airflow, the airflow, as you can see here, it's angle of incidence that we build in there. Now, as I mentioned last time, I could get 10 pilots in there, you'd have 10 pilots and 14 arguments about what causes lift. Is it Bernoulli's principle, or is it Newton's third law, also known as skipping stone theory? It's probably a function of both. All right. So and the Bernoulli's principles, air's got to go faster over the top. You lower the pressure. That low speed, that high velocity means low pressure. This one's got low velocity compared to the top one, so that's considered high pressure. That's basically Bernoulli's. Troubles with both theories, explaining everything. Here's Newton's third law. That is the skipping stone theory. The air sitting here, coming out here, this wants to go up the opposite way. Think of doing a kite. Kite only goes up when you're pulling the opposite way. The kite responds by moving the opposite direction. All right. Now, drag, we looked at drag in terms of flaps because they do two things. They slow the plane down by adding drag, but they also increase the lift. We found that lift is a function of airspeed, right? So if you just slow it down, you're going to get a lot less lift. Flaps help slow it down, also increasing lift so you can land slower. It's easier, it's safer. All right, so there it is. So the airplane you use in that one is the King Cobra. We'll just jump to that. And again, we'll select this, the different components. And what you end up doing in this is you'll put down the landing gear and see what that does to airspeed. Here are the flaps, like I mentioned, both lift and drag. And you start collecting data on this, so you get really a lot of science, a lot of data on that. There's two types of drag: parasitic, that's when you stick your hand out of the car. Induced is the result of lift. All right. Induced drag is because when you create lift, you create some drag. But it's like 100 parts lift to 1 part drag, so it's a really good deal. So that's what we do, and it works. All right. All right, that's where we got to last week. We're going to pull back up here with thrust. Now I'm going to show you some videos and some of this. All right, so there it is. So when we're landing, again, you've got, we again remind the kids what forces are, because we don't, if they have this class once a week or something, I think it's good to keep reminding. You're going to do a final approach. You can, what people don't understand with landing, it's the hardest thing on an airplane. It's the hardest thing on an airplane, but it's the last thing to do. You have no option. Once you commit to flying, you got to land it. So, but what people don't understand is you control landing with your throttle, not by pointing the nose down. If you just point the nose down, you're going to increase airspeed, which increases lift, which is the last thing you want. You know, you're trying to get to the point where you lose some lift and the plane comes down. All right. And you can add throttle to get this. When you start off with like 2200, if you lower it to 1600 RPMs, you'll be pretty well. And your airspeed around 85 knots. With the PAPI, Precision Approach Path Indicator, you get all red, you're dead. Half red, half white, you're all right. All white, you're too high. So in the first one you see up there, it's all white, you're coming in too hot. Red, white, you're coming in great. Once you touch down, you apply those brakes. And first few times, people don't necessarily do well landing, just like in the real world. Again, and before, and then when you add flaps to your landing, it even makes it easier. You know, and we go through all that, and it allows you slower speed, allows pulls down, and that's why I can go, because I've added drag. I can go slower and still land. Anytime you can land slower, do anything slower, it's usually easier. And you end up there, you can land on an aircraft carrier, you can land off an aircraft carriers and waves. That's a fun. Now, if all you really want to teach kids to fly, you could do all 5 of those lessons in 1 week, and you'd be fine for teaching somebody how to fly, plane, and how it works. And might be totally appropriate for your program. The next lessons start to transition from science to engineering. All right? And that's what we're going to go to next. In this case, by the way, in the 5 trying challenges, you can go to the aircraft carrier situation and try landing this at night. You should do it. Look, you should see how small that boat is when you're coming in out of the middle of nowhere in the ocean. a business partner who's 94 years old this month. He flew 500 carrier landings. And he told me by far the scariest thing was flying away from the carrier and trying to come back in the ocean and find it. I can't imagine. All right, so that was 5. And we can show you this. So here's a video. I'll just show you. And the video of this video is like 16 minutes, so you can show it. So they're really going to go through it.
Select File, Quick Flight Setup, type KSEA into the airport search bar to select the Seattle-Tacoma International Airport. Make sure you have the Cessna 172SP aircraft selected, and select Day and Clear. Let's fly with these options. Click P to pause the simulator.
I'm using a video because if I did the software, it would look really laggy.
Or click on this brake light to turn the brakes of your aircraft off. Use the down arrow key on your keyboard to reveal the throttle. We are going to push this in all the way to turn our throttle to full power. You can also use the mouse wheel or the F2 key, but only if you are unpaused. Go ahead and use our mouse to push that in all the way. And use the up arrow key to resume view. Click, and a box will be revealed around these crosshairs. That's how you know you can control your plane.
It's hard to see up here, folks, but there is a box there.
The plane is going to want to drift to the left naturally. So start with your mouse slightly to the right of these crosshairs. You can now press P to unpause, and you can start taxiing down the runway.
Notice it's pulling to the left, so she's got to pull the pointer to the right.
Keep an eye on your airspeed indicator, and when you reach about 75 knots, slightly move your mouse down to take off.
Equivalent of pulling the joystick back, and you're going to take it off.
You're in the air. Press P to pause. To restart a flight,
So you get the gist of it. It will walk you through flying the airplane. All right, folks. Now, under stability, we start transferring over from purely science to some applied stuff here. What is stability? Raw and yaw, pitch. Stability, roll and yaw. And how we do center of gravity and torque. You can go into as much of this as you want with your kids. We explain that a feather, and it's a great time to talk about a negative feedback loop, that feather is a negative feedback loop, that if you blow on the arrow with its feathers, it can correct for that. One lab I've done with this is I take my students out and I had to have them take a stick with a little bit of clay, take a stick, nothing on it, and throw it at a bush. Pretend it's a mastodon and you're trying to protect your family from getting run over by the mastodon. Then we put clay on the nose of the bit, go a little bit farther. But then we put basically feathers on the back end of it, and it goes the farthest. So that's a great way to teach that. And that, it'll go fine if there's no wind. But once there's a disturbance, if it doesn't have a tail, it just gets out of control. It's a negative, it's a positive feedback loop, not a negative. All right. So then we talk about the hedrals and stability and putting them on there. There's pitch stability, tail moment arm. We move every one of those things. It's really pretty actually interesting. This is, everybody says it's the center of gravity. You really balance your airplane off the center of lift, but you can't change it. So we use the center of gravity that you can't change by weight. So it's this tail moment arm, the force. It could be weight. It could be an actual, some of the tails actually create the lift upside down, like a Formula One car that keeps the car on the ground. This keeps the tail going down. It balances right along the center of lift. Center of gravity is all this weight, most of the way of the plane, and it's right there. And it's just a few inches moving back and forth from making a stable plane unstable. You can also put a flight model in, and you can see the vectors going on this. But all right, I'm going to go ahead and I just want to see now we're going science and engineering and trade-offs on this. All right. Now, and then it gets an elevator, how much you have to pull the elevators up to hold the airplane up, that kind of thing. Then when we get to lesson 7, now, I will say this. All right. If you look at that curriculum, if you look at our curriculum, we just got into flight stability now. 1, 2, 3, 4, 5. There it is. Used to be 6. Gives you an idea. Now it is 6 actually. And pressure and airspeed, like I said, are optional. Engineering of flight is coming up next, and that's really going to get on the engineering method using plane maker and everything else. All right. So just so you see what the heck's going on. These are the 4. All right. Now, well, I'll tell you what. Let's just go right here. So, all right, I'm pulling this up. I'm sorry. It's probably could have done this a lot better than doing it this way. I'm not sure why. I mean, do it by a slide. I apologize. Forgetting how much this curriculum is getting bigger and bigger every year. Let me just roll through that. She could have gone to page 80. I apologize, folks. Hand over here. Good, I can blow this up. Down the page. It could have gone go to page. Wouldn't that make too much sense, huh, Tom? All right, let's roll. So there's the stability. So you can look at different wing tips, and this is kind of one of the reasons I want to say. So you can actually calculate the moment arm and things on this by trying out different ideas. So there we are looking at the tail moment arm, center of gravity, center of lift. And we look at that. Then we get into different size airplanes, which then can get you into form and function. And that's advanced topics, pressure and airspeed. We calculate that. And then you can, once you start calculating that, you can calculate lift and coefficient of drag. So that's all that. All right, here we're coming up to what I wanted to hit next for today. Page 100, I should just gone to 100. Apologize. Engineering of flight. I'm not sure what that. All right, here we go. Aspect ratio. All right. What we try to do with this, so when you get an aspect ratio less than 9, sorry, my voice is really just tearing me apart. Aspect ratio, we want to start to use for math for a tool. So one of the things we do is just by looking at aspect ratios, we can say if the plane would even have the ability to take off, and then calculate those out and realize you can't even, the first wing there's, the wing's too short. And then what we do through here is we go with this choice up here, and we go into Plane Maker and we fill it out. So what I'm going to do is pull that up. That's kind of what I wanted to do. Then I'm going to go into Plane Maker. So let me see if I can bring this up. Plane Maker is, you'll find Plane Maker. That'll be that way, of course. All right, let me go here. All right, I'm going to go to X-Plane. If I go into Plane Maker in here, I can bring it up. It's going to be by X-Plane itself. So this is what everybody should get. All right, and here's standard. What we do is we'll open an airplane. Go to Aircraft. Go to General Aviation. Then we'll go to X-Plane. Well, that's X-Plane's thing. So let's go to, where's RV band? General Aviation. Bear with me. Let's go back in your file. Open. Experimental. Where am I getting my bands? I'm looking for my band RV. Found this. Bear with me. Yeah, here we go. It's under, I've tried to get there to begin with. Experimental aircraft, van RVs. And a van RV 10 right there. So we open that up. And then what we can do on this is we save it. We're going to save it a different name, and that gives you in there. And the reason we're doing that, I'm just going to call it safe this time. What that's going to do is, or you can make it mule. Tesla's and test mule. We don't want to mess up the original RV10. We want to save, want to make sure it's the mule on this. All right, now if I go back into my screen, that doesn't drive me crazy. If I go back over here, your first name 50 will be one. It's going to end up with a 50-foot wingspan. First name 40, and you can do it. Another way to do that is first name AR50. So if you're going to keep that naming convention, you'll just keep doing it over and over that way. Okay. So let me go over here and back over to Plane Maker. So we'll make, in my case, I'll do File, Save As. We might do it this way. So you go RV10, say Tom, 50. And if you want to say what you're doing on the slab, aspect ratio. Save that one. Then do File, Save As. and then you're going to do 40. That's what you're going to have your students do. So they mess up the original. Okay? So there we are with some of these. Now let me see if there's any questions. I'm going to pull it right up here. Okay. Now, I'm going to stop at that point here with the plane maker. I went purposely fast to the first 5 lessons because we did them last time. I'll make sure the webinar's up. Any questions on these right now? Raise your hand if there are. All right, John, I'm going to try to answer your question. Yes, John, you got a question?
Yeah, can I use the, I've got a CH Products Flight Sim yoke and pedals. Can I use that with the software?
Oh, absolutely.
Okay.
Absolutely.
Cool. Thank you.
So you can definitely do it. Sometimes use the mouse on that. It's funny, right now we're actually working on some hardware to go with this stuff that we think schools could use. Since they already have a joystick, throttle control, some other things. Pretty robust, heavy, lightweight. It's small, portable, dense, though it doesn't move. It can take abuse that you would get in a classroom. But that'll be more down the road. All right. Pardon me. No questions on this so far. All right, so I'm going to go back to File. I'm going to open, and I'm going to select Tom AV50. There it is. Now, I'm going to bring up, hopefully my file here. Go ahead. That's just annoying. All right, so I'll write this down. We'll take this. So everybody go ahead and bring up Plane Maker. If you've got a computer here, go ahead and bring up Plane Maker. This is in the outline. All right. We have slides for this as well. You're going to see wingspan is 50 feet. Wing 1, semi-length then is 25 feet. Wing 2, lateral is 24.95. Wing 2, vertical is 0.25. All right, so that's where that's coming from. Let's go down to the plane maker. Let me show you what we're doing. So if I go into here, I'm going to standard. Wait a minute. Standard, I'm going to go to wings. All right. Then with wings, wing 1, we're going to make semi-length at 25 feet. Watch my plane down here. It's getting a much longer wing. All right. So if you look, it's now got a much longer wing. All right. If I hit the space bar, it's going to have wires. Sometimes for some people that's easier to see. All right. But if you really look at this, you're going to see that when you do that, you've actually, part of the wing got left behind, the very wing tips. Let me see if I can get out there and show that. See the wing tips are here and here now. They need to be out here on the wing tips. So what to do? Well, go back to the wings. Go to wing 2. Now under wing 2, where it says lateral, let's go ahead and move those wing tips. We're not going to change their length necessarily. We're just going to change where they are. This one's going to be 24. .95, and vertical is going to be 0.25. So now I'm at 2.5. We got that. My wingtips are now, if you can see them, right there on the edge where they should be. I'm going to hit accent. There it is. I've got my plane. The wingtips are out on the edge. Then I'll hit save. Save as. Make sure it's what? Tom 50-foot aspect ratio. Make sure you do that. If not, students will mess up that example plane if they save it just as an RV10, and then you'll just have to reinstall software and get a hell of a plane. A little bit of a pain in the neck. All right, so there we are. We've got our plane. We're going to go to now I'm going to bring up X-plane. Might take a little bit to bring it up. No, I'm just going to get to this. It'll ask you, do you have to unlock it? You just sit there and say okay every time. It's a little bit of an annoyance. All right, it may take a few minutes to load up here because I'm running an older Mac. I'm at school, but there it is. It actually came up pretty quick. So when you go to aircraft, not surprisingly, we can go down to here. And let's go to here, experimental. Van RVs, RV10. If I keep selecting, there's my 50-footer. If I go to flat, I'm going to see it out there. So the actual plane your kids design, they can fly, and it will fly differently. It will calculate, well, what does the aspect ratio do with this? It's waiting for it to roll up here. It's reading the summary files. Give us a minute here. Any other questions while my thing loads off that? All right, John's got it. All right. Yeah, John.
Yes, sir. I just wanted to ask, like all the videos and everything that you were showing earlier.
Yes.
I saw that in the email that you sent back, and thank you. Can we just get access to all that?
Absolutely.
Okay.
Absolutely.
So do they have to go anywhere, or because that's not something that was part of the curriculum? I just didn't know.
No, those videos go with the curriculum. So the first 5 videos correspond basically with the first lessons. We didn't do videos, for example, on the theory of, for example, calculating coefficient of lift or anything like that. I mean, if people want us to do that, we'll do it. We just didn't see there was a need. Okay?
No, that's fine. I was a pilot for 20 years, so it's.
Oh, you'll be awesome. Now, if you look up here on the screen, everybody, you can see that airplane's got a 50-foot wingspan. I'll get it right there. So, John, I didn't mean to mute John there. But there's a 50-foot wingspan there now. And this plane, if you compare it, will take off at a shorter distance than a 30-foot wingspan. Remember up here, we collect data. No, I've got it up here. I'll show you. Go under special. All right. Well, that's, all right, excuse me, data input, output on the settings. I almost went to the contest. So if I go here, distance traveled, I can measure that. I can go to vertical forces, gear vertical forces, 66, and I can go to speeds. And if I go on there, they're right there. And if I go to take off, remember, I'd hit the pause it, hit the brake, push in the throttle. Tell you what, let's do W. I push that throttle all the way in. Now I'm ready to take off inside that box. And then I can measure. Let's see, it might look choppy to you. I'll try it. See, plane's gonna want to pull to the left. All the data's on there. Getting students to fly consistency is probably the hardest thing. Let the airplane take off. It will take off a little bit. Ever so slightly. Pause. And you can get them to either say, hey, always make sure your pointer's right below the cross. Just get them to be consistent. Now, if I go to settings, data input output, and go data C, I can see where the plane, right here, all three of the landing gear noses are off. So right there is takeoff. And so what I can go over here is say, get rid of the lines we don't really need. V true miles per hour ground speed. I'll leave that light blue in there. That's V indicated. That's indicated airspace. Let's go down to here. Here's distance traveled in feet. You do it in meters, makes no difference. And there where I go. So I go right up there and go, okay, traveled a distance of 960 feet. Or, and it was speeding along at true airspeed of about 86 miles per hour. So and then you just see you have them fly consistently. All right. Okay. Any questions about that? And that's in a lot of ways, you're just going to keep throwing in plane maker, changing parts of the airplane, and having it fly differently. Okay? Any questions there? Okay, let's go on to the next lesson. Go ahead back over here. So, and that's really what we're going through with that. And this is why it does a lot of good science. It does calculations, average takeoff distance, all those kind of science things. We also get into trade-offs. Why doesn't every plane, if it's shorter takeoff distance, have a high aspect ratio? Then we get into wing loading. And this basically is you're adding weight to the airplane. You're increasing the load factors on the wings. And we look over that and trade-offs that go with that. Finally, shall we get into questions about, if we start doing what we're trying to start stressing some of this is there's trade-offs for everything. There's a reason airplanes start looking very similar. Form usually always follows function, and engineers are just trying to optimize those choices. It's only when we get new materials out and stuff that we can start advancing things. All right, let me go back over here. It's good my voice is about had the best of it. All right, let's go back to on here. I do want to get to the next one. Power loading is we just start looking at horsepower. And then when you get to, after looking at power loading and what it does to flight performance, we then go on to the next lesson, which, Lord, you can literally go through the design process of designing a simple airplane. The idea of iterating, the idea of here's a plane and we can do all these calculations on it. All right. So, and the kids make choices and they do the calculations each time they're coming down, though. Funny why, not one sure I got the clip on this clipped off, but it did. That's strange. All right. So there's a way do that calculation, then wing loading. Wing area, wing span. You're going to start calculating on, say, weight, then using standard wing loading, you calculate what that's going to be once you have the high wing loading range, the slow wing range. You can make decisions based on that to calculate your wing area. And from there, you can calculate your wingspan. And then you fill out this table and build it in PlaneMaker. From there, you can actually start going on into gliding, and we have lessons for designing the airstrip. Okay. All right. So for right now, that's where we're at on this. I kind of went quick, but we're happy to shower the power slide so that we can go in a deeper dive if you like. I've automatically added 2 more webinars. They're totally free. You've signed up. When you signed up, I just added to them. You don't have to come back if you don't want to, but I will come on if you'd like and go into any greater depth on this that you would like. So I may suggest that next week or so, fly this. We'll get back together on the Tuesday. I'll answer questions. When we get close to the contest, we'll go into airplane design for the contest. All right. Let me launch a poll here real quick. How was my pacing tonight? Yep. Not surprisingly, if I get more than 63% to vote, I'd appreciate it. So at 88% have voted, 5, 4, 3, 2, 1. Share results. A little bit quick. I was worried that I'm trying to get people caught up. I will try very hard to have both webinars posted up here tomorrow and Fly to Learn so you can get them over the weekend so you're linked onto them, you have them. And on our YouTube channel. Then, was this useful? Again, appreciate your feedback on these. 75% beneficial. All right. Well, I appreciate you on that. 88, 5, 4, 3, 2, 1. Share results, and I always do. All right. Now, again, this was recorded. I'm saving it. Any other questions before we hang out? How many people do this for me before I close? How many people think they want to come to another webinar? So I know, or they feel like, yeah, we got it. All right. Okay, great. All right. Then I'll do another one. We can do a deeper dive on this. Okay. Tell everybody. I'll put the word out again for folks that may have missed it. Maybe their teams now gets closer to competition. They'll be wanting to do it. All right, everyone? All right. Hey, have a great day. I'm at Tom at .flylearn. I'll tell you what, before you get off here, also, let me send you this. Let me go send it. me see here. Bear with me one second. Chat. Here's my email. If you have questions or what you'd love to see covered on the next webinar, just drop me an email. All right. Okay, I've got another group of students coming in. I'll talk to y'all later. All right. In case you're wondering, I do enrichment classes. We don't normally teach at my school at 8 o'clock at night. Unless it's Tuesday night and all their engineering projects are due, and then they're out here pretty late. All right. Y'all take care, okay? Bye-bye.